Now that we know what the leading coefficient, how to identify that, and the degree of the entire polynomial, we're going to look at those two things to determine what um, what the graph's going to look like. Because those two things can tell you a lot. There's basically four categories it can fall into: the degree of the term of the the degree of the entire polynomial function can either be odd or even, and then that leading coefficient will either be positive or negative. And those two things in conjunction will get it to fall into one of four categories, right? So the first thing we're going to look at is an odd degree and a positive leading coefficient. So here are three examples of that scenario. So f of x equals x, that is a degree of 1, so it's odd, and the leading coefficient is 1, so it's positive. And that's just a line that goes y equals x, right? It's just that diagonal there. You've got a degree 3 function here, a cubic function, so degree is 3. That's the blue one. Leading coefficient is a half, but it's positive, and that's all that matters in terms of our discussion here. And then the green one is a fifth degree function. Leading coefficient is 2, positive. Notice what they all do. They all are seeming to go from left to right. They're going up, right? The end, this is how we're going to describe it mathematically, but just in more layman's terms, from left to right, it's going up. So the end behavior is similar to the linear parent function f of x equals x, where as x approaches positive infinity, so meaning as you're going right, the y is going up. That's what that positive infinity means. So on the right, it's going up. As x approaches negative infinity, so like as it's going to the left, y is going down. So it's falling to the left, it's rising to the right. Okay. One side is going up, one side is going down. Let's look at odd degree negative leading coefficient. So I'm going to skip over that even degree one because I'm going to compare it to what we just looked at. So let's get rid of that. So when the degree is odd, notice how it's very similar functions. Are they even exactly the same? Potentially. At least the leading coefficients seem to be just opposites. But anyway, what you've got here is pretty much the opposite. So when the degree is odd, again, one side is rising, one side is falling, right? When the leading coefficient is negative, it flips, it's opposite. So now it's rising to the left and falling to the right, right? Mathematically speaking, as x approaches infinity, positive infinity, so as x is going to the right, as the function is going to the right, the y is going down, all right? And then on the next line here, as x approaches negative infinity, so as it's going to the left, the y is going up, all right? So the big takeaway here is when the degree is odd, the end behaviors are opposite. Like one side's going up, one side's going down, okay? Let's look at the second one here where it says even degree and a positive leading coefficient. So you got your three examples here. You got f of x equals x squared. That should look familiar from last chapter, right? That's just a parabola. Degree is 2. Leading coefficient is 1, so it's positive. You've also got a degree 4, that's the blue one, and degree 6, which is the green one. Both have positive leading coefficients as well. Notice what's happening. On both sides of all three functions, it's going up, right? So the parabola, remember, it always goes both directions are the same. It's either both going up or both going down, right? So if you look at the mathematical breakdown of what's happening here, as x is moving to the right, y is going up. As x is moving to the left, y is also going up, right? So when it's an even degree and the leading coefficient is positive, everything is going up. The end behavior of each side of your function will be going up. Now let's look at even degree and a negative leading coefficient. So essentially it's the opposite of what you just saw for even degree positive leading coefficient. When the leading coefficient is negative and the degree is even, everything goes down, right? So on the left, it goes down. On the right, it goes down. If I look at it mathematically on that table, that's what it's describing. As x approaches to the right, the y is going down. As x moves to the left, the y is going down. Everything goes down in that case. So when the degree is odd, the end behaviors are opposite. One side goes up, one side goes down. When the degree is even, they both do the same thing, and it depends on what the leading coefficient is. All right, so now you got two examples. Why don't you try to figure out what you think both are going to be doing, and then, pause it and then come back and then see if what you got matches what I got. So look at the first one here. The degree is 6, so it's even, and the leading coefficient is 2, so it's positive. So that's a situation where both sides are going up. So if you want to break it down mathematically, as x moves to the right, y will go up. As x moves to the left, y will go up, right? Both sides are going up. For part B, the degree is 3, so the degree is odd. The leading coefficient is -5, so it's negative. That's a situation where it's going to rise on the left and fall on the right. So as x moves to the right, y will go down. As x moves to the left, y will go up. So it's falling into those two categories there. All right, let's look at the next example.